Dear friends, today we are going to talk about the distribution of various major groups of fossils. The present theme embraces the distribution of the 4 groups of fossils, including Mollusca, Arthropoda, Echinodermata and Brachiopoda in time and space. Coming to module 1, that is the distribution of the Mollusca. All the mollusks are mostly aquatic animals, and by far the larger number are marine. The marine forms range from the shoreline down to a depth of 2,900 fathoms. They are most abundant in shallow water and are scarce at depths greater than 500 fathoms. But the following and a few other genera have been found below 1,500 fathoms, that is Nucula, Nuculana, Area, Lymphosis, Malacia, Verticordia, Cuspidaria, etc. In England, the earliest forms appear in the lower Ordovician. Lamellibranchs are not usually common in the Ordovician, but the Taxodonta, Mytilacea, Pteriaceae and Paleoconcha are represented. These groups continue throughout the Paleozoic, the Paleoconcha being especially characteristic of the Ordovician, Silurian and Devonian. The schizodonts are well represented in the Carboniferous and Permian by Schizodus, Carbonicola, etc. The Pectinaceae begin in the Silurian and become numerous in Upper Paleozoic. In the Carboniferous, the Paleoconcha are represented by Edmondia and Sanguinolitis, Alorisma, etc. That is Carboniferous and Permian, which is one of the few Paleozoic genera with a pallial sinus. Lamellibranchs form an important part of the faunas of Mesozoic and Tertiary formations. Most of the Paleozoic genera die out before the beginning of the Mesozoic. In the Triassic, the Pteriaceae, Pectinaceae and Mytilacea are abundant. The Ostraceae and Anomiaceae are now appear, that is the Schizodonta, Heterodonta and Desmodonta are represented by a few genera. In Jurassic and Cretaceous, all these groups increase in importance. The living type Unio has been found in the inferior oolite of Yorkshire and is fairly common in the Pubacian and Wildian of the South England, where it is associated with Sirena. Freshwater lamellibranchs also occur in the Woolwich beds of the Oligocene deposits and in the Pleistocene river gravels. Some of the gastropoda live on land, others in freshwater, but the majority are marine. They are found in the seas of all parts of the world, but are especially abundant in warm regions and in comparatively shallow water. A few forms can exist both on land and water. For example, Ampullaria, which commonly lives in lakes and rivers and is also found on the land. Some marine genera such as Littorina, Cerithium and Thias, that is Purpura, are able to live in fresh as well as the salt water. On the other hand, some freshwater forms are at times found living in the sea. For example, Limnaceae, Theodoxus, that is Neritina, Bithina and Planorbis. This is especially the case in places where water is less saline than the main mass of the ocean. As for instance in the Baltic, where we find the genera just mentioned living side by side with Littorina and with marine lamellibranchs Cardium, Telina and Maya. The Opistobranchiata are entirely the Prosobranchiata, mainly marine. Nearly all the Pulmonata are found on land or in fresh water. In the Paleozoic and Mesozoic formations, gastropods are generally less abundant than lamellibranchs, but they exceed them at the present day. The earliest forms occur in the lower Cambrian beds. Throughout the Paleozoic formations, the holostomatous prosobranchiates are predominating forms. No gastropods with a well-developed canal are known to occur until Triassic is reached, but Giphonostomatous genera become fairly abundant in the Oolites. They increase still more in the Cretaceous, and in the Tertiary they are principal forms. The Heteropoda are represented by a few forms only, the first occurring in the Miocene. The Opistobranchiata range from the Carboniferous to the present day. They are moderately well represented in the Jurassic and Cretaceous formations and become more abundant in the Tertiary. Pteropods belonging to living types are found in the Upper Cretaceous and later formations, and earlier forms which may belong to this group occur in the Paleozoic. Marine forms Pulmonata appear first in the Devonian, that is non-marine forms, for example Anthracopupa, are found in the Carboniferous and become abundant in the Tertiary. At the present day, the Nautiloidea are represented only 4 species of Nautilus, which are found in the Indian Ocean and the East Indian archipelago, that is from Sumatra to Fiji. Nautilus lives in fairly shallow water, either crawling on the sea bottom by means of the tentacles or swimming, but sometimes rising to the surface of most of the sea. Most of the extinct nautiloids probably fed a similar benthonic mode of life. This group appears much earlier in the geological series than either the Ammonoidea or the Dibranchia. The early forms are single or slightly curved cones. Subsequently, straight and spiral shells appear, but the straight or nearly straight forms predominate in the Paleozoic and Triassic. Volbothella and Saurella found in the Lower Cambrian are regarded by some of the authors as primitive nautiloids. Curved forms resembling Cetoceras extremely appear in the Upper Cambrian. In the Ordovician, the Nautiloidea increase in importance, like Endoceras, Pleoceras, Liloitis, etc. And the group attains its maximum development in the Silurian, where the number of species is very great. Orthoceras, Gomphoceras, Phragmoceras and Ascoceras, and the helicoid genus Trochoceras. It decreases slightly in importance in Devonian and Carboniferous and is but poorly represented in the Permian. The chief genera in the Carboniferous and Orthoceras, Rhinoceras, Proterioceras, Dictyoconites, Vestinautilotus, Cadmatulotus, Pleuronautilus, Temnochilus. The only genus which extends beyond the limit of the Paleozoic period is Orthoceras, which is common in the Triassic. Nautilus occurs first in the Triassic and is abundant in the Jurassic and Cretaceous. When its distribution seems to have been worldwide, in the Tertiary it is relatively rare. Etruria appears in the Eocene and Miocene. The Ammonoidea have a shorter geological range than Nautiloidea, the earliest representatives being found in the Lower Devonian and latest in the Chalk. The most primitive of the ammonoids and apparently the ancestral forms of the Goniatitis, Agoniatitis from the Lower Devonian differs but little from some Silurian nautiloids, that is Barandoceras, except in the greater sinuosity of the superior lateral lobe, in the external position of the siphuncle, and in more closely coiled early whorls, but similarly closely coiled whorls are seen in the Lower Ordovician. Nautiloid Trocholitis, Lobobacteritis, that is Bacteritis, found in the Middle Devonian, has often been regarded as the ancestral form of the ammonoids, but is now believed to be a secondarily coiled goniatite. It possesses a straight tapering shell with a simple superior lateral lobe. Throughout the Devonian and Carboniferous periods, the Goniatites were dominant, with the Climanids abundant in the Upper Devonian. In the history of the various groups of Goniatites, there is a general tendency for the suture line to become more folded, for the septal necks to change from retrosiphonate to prosiphonate, and for the sinus in the external margin of the aperture to decrease in size and ultimately to disappear. The various gonatite stocks that persisted into the Permian gradually took on ammonite characters until in the Upper Triassic the maximum of the development was reached. Although most of the ammonites in the Triassic evolved complicated suture lines, some like Ceratitis remain relatively simple. The number of genera in the Triassic is very large, but not one seems to have survived into the Jurassic period, and only the family, that is the Phyloceratidae, passed from the Triassic into the Jurassic, so that apparently all the later ammonites must have been derived either directly or indirectly from that family. Two families, the Phyloceratids and the closely allied Litoceratidae, are remarkable in that they persist with but little change throughout the whole day of the Jurassic and Cretaceous periods. Numerous other groups of homininoids were evolved in the Jurassic and Cretaceous, but the possibilities of the variation were limited, and the same types of wall section, ornamentation and suture line were often reproduced in the various families and at different horizons. In the Triassic and Jurassic, there are some genera in which the shell has become secondarily straight, that is the Babdoceras, Aulacoceras, partly uncoiled, Choristoceras, coiled into a helicoid spiral, that is Cochloceras, Spiroceras, etc. This feature becomes much more marked in the Cretaceous, where we get such genera as Hemites, Macroscephitis, Baculitis, Crioceras, Escephitis, from which are believed to have been derived from various litoceratid ammonites. In the Cretaceous, there is a tendency in some stocks for the suture line to become simplified, and occasionally it returns into the type seen in Ceratitis. On the other hand, in Indoceras, the latest of all the ammonoid genera, there is no sign of simplification. Its suture line with 75 elements, lobes and saddles, recalls the acme of specialization. Amongst the Triassic ammonoids, the dibranchia are more numerous and more varied in existing seas than they were at any former period. Some forms are pelagic, others are abyssal, but the larger number are found in littoral regions and are distributed in provinces similar to those of other mollusks. Typical littoral genera are Octopus, Sepia and Loligo. The suborder Decapoda is represented in the Triassic by Atrocities, Aulacoceras, Dictyoconites and Phragmoteuthis. In the Jurassic and Cretaceous, belemnites are the chief forms and are especially abundant in argillaceous beds. Other Jurassic genera are Geoteuthis and Beloteuthis in the Lias, Belemnoteuthis and Plesioteuthis in the Upper Jurassic. Belemnitella and Actinocamx are limited into the chalk. The tertiary dibranchs are relatively rare, but several genera are found: Belosepia, Sepia, Belemnosetta, Belemnosis, Beloptera, Spirolirostra and Spirolyrostrina. The living form Spirilla is not definitely known to occur as fossil. The suborder Octopoda is represented by Plesioctopus, that is chalk, and Argonatula, that is Pracy. The distribution of Arthropoda. The trilobites are confined to the Paleozoic period and form one of the most important striking features in the faunas of the lower Paleozoic deposits. They occur first in the lower Cambrian beds and reach their maximum in the Ordovician. In the Silurian, trilobites are still abundant but become less important in the Devonian. Only one family survives from the Devonian into the Carboniferous and is represented by 4 or 5 genera only. Trilobites have been found in the Permian of Sicily, the Crimea, the United States, China, Timor, and Western Australia. Already in the Cambrian period, the trilobites were represented by a considerable variety of forms, showing that even then the group must have been of considerable antiquity, but at the present no traces of the ancestors of the Cambrian forms have been found. It is in the Cambrian system that we meet with the largest as well as the smallest trilobites, for example Paradoxides and Agnostus. As a whole, it may be said that the trilobites which are confined to the Cambrian periods are characterized by the possession of a large number of thoracic segments and of small pygidium, whereas in the Ordovician most of the characteristic genera have fewer segments in the thorax and possesses larger pygidia. They became extinct in the Upper Permian for no time to come back. Now coming to the ostracods, which have a very wide distribution at the present day. Many forms are marine and some are abundant in fresh water. The marine forms often occur in shoals. Some are pelagic, but others live on the seafloor and are more abundant in shallow water than in deep water. Only 52 species being found beyond the 500 fathom line. The fossil forms are very numerous, the earliest occurring in the Upper Cambrian, that is Lepetida, Primitia and Berichia are abundant in the Ordovician and Silurian. Entomis in the Devonian and Cypridina and Beridia in Carboniferous. Cypridia is common in the Purbeck and Wieland beds and Citre in the Tertiary formations. The cirripedes are all marine and greater number is found in shallow water, particularly near coasts, Balanus being especially characteristics of the littoral regions. At depths greater than 1000 fathoms, only 2 genera, that is Scapulum and Verruca, have been found, and these are not confined to deep water. The earliest undoubted cirripedes at the present known as Prodepas from the middle Carboniferous of the Donets and Cusins basins of the Russia. In addition to this genus, Archaeocephalus and a few others are found in the Jurassic. In the Cretaceous, there are various stalked cirripedes such as Zygmatolepas, Calantica, Crete and Calpellum, Scapellum, Archoscapellum, Virgiscapellum and Stramentum, that is Loricula. From the Carboniferous into the lower Cretaceous, all the cirripedes are stalked forms. It is not until the Upper Cretaceous that we find sessile cirripedes represented by the genera Proberuca, Verruca, Pycnolepas, Brachylepas and Catophragmus, that is Pachydiadema. There is evidence to show that 3 separate groups of sessile cirripedes have been derived independently from stalked forms. Proberuca from the chalk is of interest since it forms a link between stalked Scapelida and the sessile Verruida. In the Tertiary, cirripedes are more numerous than the Mesozoic. Balanus and Lepus appears in the Eocene. Metella, that is equal to Polycypus, is not known for certain as a fossil. The only record of insects from the Devonian is a few small specimens from the Rhynie chert, that is the Old Red sandstones, which are believed to be Collembola. But in the coal measures and in the Permian, the group is represented by a considerable variety of forms. Remains of insects have been found at many horizons in the Mesozoic and Cenozoic formations. In England, they are not uncommon in the Lias, the Stonesfield slate of the Purbeck, the Weldon and the Burnbridge beds. They are well represented in the Stollenhofen limestone, that is Upper Jurassic of the Bavaria, in the Miocene of Oningen in Switzerland and of Florestan in Colorado. And in the amber from the Oligocene beds of Prussia, the insects found in the Paleozoic formations appear to be more generalized than the latter forms, and the majority are referred to orders distinct from those found in the Mesozoic and latter periods. The distribution of Echinodermata. The Asteroidea have a wide distribution in the ocean at the present day. They are most abundant at moderate depths, but also occur in the abyssal regions. The majority of ophiurids live in shallow water, more than half of the known species being found at depths of less than 30 fathoms, and most of these not extending lower. Other forms occur at greater depths, some species being found below 1000 fathoms. The earliest representatives of the Astrozoa at present known are found in the Upper Cambrian. Complete specimens are usually rare as fossils since the skeleton readily breaks up after death. But at some horizons and localities, numerous examples have been found with lower Ordovician, Bohemia, Wenlock beds of Gutterford, Burn, Pentland hills, Herefordshire, Lower Devonian, Budenbach slates of the Rhine, Coralline calcareous grit of Yorkshire, Upper Chalk of Bromley, Kent, etc. Some echinoids live at greater depths in the ocean. No less than a dozen species have been found below 2000 fathoms line, and one even at 2900 fathoms. But by far the larger number occur near coast in shallow water. Of the 297 existing species recorded by Agassiz, 201 are found in water of less than 150 fathoms in depth. Echinoids are most abundant where the sea bottom is rocky, sandy or calcareous, and less common where it is muddy. Consequently, fossil forms are rare in clayey strata. Those found in deep water have much wider range in space than those found in the shallow water. Many genera, especially those with a considerable range in depth, have also a long range in time, some extending back to the Cretaceous or even to the Jurassic period. For example, Hemipendina, Calopygus, Flatellina, Hemiaster. All the Paleozoic echinoids belong to the endobranchiate division of the regular group. With two exceptions, the corona is characterized by consisting of more than 20 columns of plates. In the ambulacral area, the number ranges from 2 to 20. Each plate has one pair of pores, so that in some cases the number of tube feet in each area was very large. In each interambulacral area, the number of columns varies from 3 to 14. Some forms have a rigid test, but in many genera the plates of both areas overlap, so that the test was flexible. Echinoids are rare in Paleozoic formations, especially in the Carboniferous age. The earliest representatives are found in the Ordovician. Bothriosidaris from the Upper Ordovician of Russia has been regarded as assisted, but it is more probably an echinoid of the peculiar type, differing from all other genera, having a single column of plates in each interambulacral area, and in the ambulacral plates being as large as the interambulacrals with which they alternate. Also, the pairs of pores in the ambulacral and placed vertically, and the test was rigid. In Olacninus from the Upper Ordovician of Giran and in the Myra stitches from the Middle Ordovician, there are numerous columns of ambulacral plates, and the test was flexible. In the Cretaceous, the echinoids are even more abundant. The distribution of Brachiopoda. The brachiopods are all marine and found in all parts of the world. In the present time, they are much less numerous than in the former periods of the Earth's history, there being only about 175 living species belonging to 60 genera. Of these species, 38 are inarticulates, 137 are articulates. Brachiopods are most abundant between 15 and 100 fathoms. Their relative scarcity in the littoral zone is probably due to the fact that most of them are attached by pedicle and would essentially become displaced in the rough waters of the shallow sea. As a whole, the Brachiopoda are characteristics of the shallow water. Below 150 fathoms, they soon become comparatively rare. But some species occur in deep water and in abyssal regions down to 2,900 fathoms and are characterized by their thin shells. The majority of the inarticulata are found between low water mark and the depths of 15 fathoms. Of the remainder, all but one occurs between 15 and 100 fathoms. The principal littoral genera are Lingula, Distinct and Dysnesia, which extend from the shoreline to a depth of about 20 fathoms. The littoral and shallow water species characterize warm seas and are more numerous and possesses thicker and often larger shells than those found in deep water and abyssal region. Crania range from 2 to 800 fathoms and is the only inarticulate genus living in the shallow water of the cooler regions. Many of these of the northern hemisphere, the articulata although represented by the 15 species in water of less than 15 fathoms deep, are mainly characteristics of the depths between 15 and 100 fathoms. Of course, the rhynchonelids do not live at depths of less than 15 fathoms and are found mainly in the deep water. They occur in nearly all parts of the oceans from the Arctic to the Antarctic regions. Some of these species are found in warm seas, but the majority live in the cool waters. Some species have a restricted geographical range. Others occur in several provinces, and one, that is Hemithyris prestacea, is found throughout the greater part of the northern hemisphere. In the depth, Hemithyris ranges from 15 to 2084 fathoms. The terebratulids are more abundant both in the individuals and species between the shoreline and depths of 100 fathoms, where 67% of the species are found. Geographically, the Brachiopoda, which live in comparatively shallow water, are distributed in provinces, agreeing generally with the molluscan province, and these can be grouped into larger regions. Each province is characterized by the presence or abundance of certain species, the ranges of which are determined mainly by climate. A few species, as for example Terebratulina, Capu serpentis, have a very wide geographical distribution extending from polar to tropical regions and also have a great range in depth, the formation being found from the shoreline down to 1180 fathoms. The species found in deeper water have generally a much wider geographical range than those confined to shallow water, and the polar or boreal species have wider range than those found in warmer regions, since in lower latitudes they can find a suitable temperature at greater depths. Since brachiopods are fixed animals, it is only in the free-swimming larval stage that the range of a species can be extended. In most genera, this stage is of short duration, so that migration can take place only in the shallow water, where there is some foundation to which the brachiopod can attach itself at the end of the free-swimming stage. Brachiopods are very abundant in the Paleozoic and Mesozoic formations and are usually well represented or well preserved on account of the fact that their shell generally consists of calcite. Thank you very much.